Okay, right. So the next topic is boric acid. Right now we have discussed when the boron react with the oxygen, we form a boric oxide. We have just discussed. So out there we have discussed about how this boron has been formed, right? Boron react with oxygen to form a boron trioxide. When reaction with water, we get the boric acid, right? This is one. So this boric acid is a weak inorganic acid with antiseptic properties, such as it is also called a boracic acid and orthoboric acid, right? So this boric acid, normally you won't get in a question, but sometimes you will get in for 1 mark or 2 mark question also. Sometimes you used to get. So the boric acid H3PO3 is the chemical formula. Sometimes it also represented in the BOH3, right? B3BO3. Okay. So this is how the chemical formula. It is a weak inorganic acid. Remember, it is an inorganic acid, right? Boric acid is sometimes in multiple choice question you might even ask, what is boric? Boric acid is an organic or inorganic? It is an inorganic acid with it has some antiseptic properties. It is also called boracic acid and orthoboric acid. Chemical formula is H3PO3. So type of boric acid, you have a 3 type. One is orthoboric acid H3PO3. This is the one that we are going to discuss its properties. And another type is called metaboric acid, right? It's when two H is removed and 1 oxygen is removed, you get this metaboric acid and pyroboric acid. So these are the 3 types of boric acid, inorganic boric acid, but we will be discussing this type number 1. So this is the H3PO3, right? So this is how this boric acid is prepared from water. When from boron trioxide. When boron trioxide is hit with the water, B3O3, when react with water, you get the H3PO3. This is one type of preparation method. Another type of method is a boric acid. BORAX. In class 12, you might have studied about sodium Na2, right? Na2B4O7 is called a BORAX. Sometimes students used to get confused, but you should not make confused of this. This is a BORAX is nothing but it is also a compound of the boron. Sodium tetraborate also it is called sodium tetraborate, right? Sodium tetraborate, because it has a sodium and 4 molecules of boron is present. It is also called, let me write here somewhere, right here. This is a sodium tetraborate also we call it, right? Sodium tetraborate when undergo reaction with mineral acid. It can be hydrochloric or sulfuric acid. It can be HCl, or when boric undergo reaction with the sulfuric or hydrochloric acid, we get these molecules H3PO4. This is a boric acid. Boric acid with release of 5 molecules of water and the sodium sulfate will be released, right? And another type method is it can be prepared, right? This when boron nitride on reaction with the water, we get the boric acid. These are the 3 important methods. And another, it can be also prepared by hydrolysis of boron trihalide. Halide also, when boron undergo reaction with the halogen, we get the halide, right? So this halide or diboron, when BBr3 or B2H, this is number 5. So when boron tribromide undergo reaction with water, we get the BPO3. When diboron, this is a diboron, right? When undergo reaction with water, we get the BPO3, BOH3. So these are the 5 important methods of preparation of the boric acid. So this boric acid is very important. The method of preparation is very important, and it is very useful for the different types of antiseptic agents. Okay, so the structure of boric acid, as we have studied that boric acid is a B3, right? H3BO3. Yeah, this was the H3BO3. This is the boric acid. So its structure is like this: BH1 2 3H also 3. So this is it is a trigonal planar. This is a trigonal planar. Boric acid is a trigonal planar. It is a like somehow like a trigonal planar structure, right? So this is a trigonal planar. It has a three hydroxide compound group, OH group, 3 OH group. And this, as we have studied that it is a boron oxygen, a single bond. Boron and oxygen is linked with a single bond. It is a single bond, and it is 3 OH group, right? Okay, so these are actually the bonding should be in the oxygens, right? It is not in the hydrogen. Hydrogen should be, this is a oxygen, okay? This is oxygen, H is a hydrogen, H is hydrogen. So this bonding, in all the bonding you have this trigonal planar structures. And our world, one point you have to keep in mind is boric acid is a trigonal planar. Bond are single bond between the boron and the oxygen and the hydrogens, right? So this is the simplified structure of the boric acid, its preparations and structure. And its properties. These properties, boric acid is very simple. You can go. It is a white, odorless crystalline solid. It is soluble in cool water, fairly soluble in hot water. It is very weak, monobasic. It is a basic in nature. Monobasic. It is a weak, basic acid. BOH3. It's or H3BO3 also, right? When react with water, you get the BOH4 minus plus H ion will be released. Its melting point is 171 degrees Celsius. As you know, the water is 100, so higher than the water, right? 100 degree, so 171 degrees Celsius. Its boiling point also, it's 300 degree Celsius, very high melting and boiling point. So this is just go through it. Physical properties. This is boric is a boric acid, H3BO3. Molecular weight is 61.83. When you calculate the molecular weight, you will get density is also 1.4. Boiling point is 158 degrees Celsius. Its melting point is this in some text you will get this, some text you will get this, but you use this. It should be in the boiling point is 171 degrees Celsius and boiling point is 300 degrees Celsius and melting point is 170 degrees Celsius. So this is the physical properties of the boric acid and effect of heat. So when this boric acid at 100 degree, when you heat at 100 degree, you get metaboric acid, right? We have discussed the three types of boric, few boric out there. We have studied the metaboric also. So at 140 degrees Celsius, when boric is heated, you get the pyroboric acid. This is pyroboric acid. At 300 degrees Celsius, you get the boric oxide. So these three also importance. When boric is heat at the different temperatures, you get following compound. So some of the uses of boric acid are like we have it is used in the manufacture of textile fabric glass. Since it is a very crystalline solid, it can be used in the fiberglass. It is used for the flat display panel. Number 3 is it can also use as electroplastic, jewelry industry, silipudin, insecticide, antibacterial, antiseptic properties. So these are some of the uses. It can be also used for the preservation of grains like wheat and rice. So these are some of the properties, uses, and the chemistry of the boric acid. I hope you have understood. Or if you have any doubt, you can ask in the comment section, or we'll discuss in the upcoming video. Thank you, everyone.